In this video, we'll be finding the area of a region between two curves, but we'll be doing it with respect to y this time instead of with respect to x. To find the area between two curves with respect to y, find the area of the right curve and then subtract the area of the left curve. The example that we'll be working with is determine the area of the region enclosed by the graphs of x equals 1/2 y squared minus 3 and y equals x minus 1. Notice I've rewritten this equation so that it's also x equals y plus 1. Now with this problem, when we see this equation, x equals, and then in terms of y, that's a good clue that we need to integrate with respect to y rather than x. But in this problem, it can be done both ways. We'll be looking at it with respect to y. Our first step is to sketch the region. Now, in order to examine what the sketch looks like, we need to take this equation and solve it for y. So we'll add 3 to both sides and then multiply both sides by 2 to get rid of the fraction. So we have y squared equals 2 times the quantity x plus 3. And then square rooting both sides gives us y equals plus or minus the square root of 2 times the quantity x plus 3. Now the positive part of this equation is the graph that starts at the x-axis and goes up. This is our positive square root of 2x plus 3. And then the negative part of this equation is the part of the curve that starts at the x-axis and goes down. Also, this line is a y-intercept of -1 and a slope of 1, so it looks like this. So when we integrate with respect to y, notice that I also drew in my representative rectangle. The thickness or the width of this rectangle is going to be dy this time instead of dx. So we're going to, when we integrate, we're going to move this rectangle from this point, and we'll find that point in a minute, up to this point, this y value. So we need to find those 2 points where the curves and the line intersect. To do that, we will solve the system. X equals 1/2 y squared minus 3 and x equals y minus 1. Since these are both equal to x, we'll set them equal to each other, and that gives us this equation, 1/2 y squared minus 3 equals y plus 1. Multiplying by 2 all the way across to get rid of our fraction gives us y squared minus 6 equals 2y plus 2. And then moving all of the terms to the left, we get y squared minus 2y and then minus 8 equals 0. This trinomial is factorable, so we'll factor it into y minus 4 times y plus 2. Once it's factored and the product is equal to 0, we can set each factor equal to 0. Y minus 4 equals 0 gives us y equal 4, and y plus 2 equals 0 gives us y equal -2. So that means then that our lower boundary, our lower limit of integration is going to be -2. So the y value here is -2. And then our upper limit of integration will be 4. and that is this y value of this point up here. Then we want to write our integration. In order to find the area, we want the right side, which is the line, subtract the left side, which is the curve. So we're integrating from -2 to 4, which is our two limits of integration, and then the line subtract the curve with respect to y. Now when we distribute this negative sign through the binomial and then combine like terms, we get y minus 1/2 y squared plus 4 dy. Just use the power rule then, increase the exponent by 1 and divide by the new exponent. So here we have y squared divided by 2, and then minus 1/2 times y cubed divided by 3, plus, and then 4y. And that's calculated from -2 to 4. The fundamental theorem of calculus says that we'll first evaluate this expression with 4 substituted in for y, and then subtract from that the value when we substitute in -2. So this first set of brackets is what we get when we put 4 in for y. And then we're subtracting from that the same expression, only with -2 substituted in for y. Right. 4 squared is 16 divided by 2 is 8. And then here we have 64 over 6. And then plus 16. And then subtract from that, this is 4 divided by 2, which is 2. And then this is -8 over 6, but I have this minus sign here. So minus 8 over 6, and then minus 8. When we do the math here, we end up with an area of the region equal to 18.